So I don't know how many of you were here for the first day, but I'm going to go over what this module is about and who I am, and that will be mostly what we do today. Okay. So we're calling this module we're calling Nondestructive Evaluation of the Human Body, but in medical terms we just call it physical exam, and I'll go over medical imaging as well. Okay. So who I am. I'm Dr. Neil Jenkins, and I went here for my undergrad and grad school, both in course 3. And when I was an undergraduate, I was all into biomaterials at first, and worked in Jonas Jonas's lab doing, I did environmental scanning electron microscopy of collagen spinal cord implants, which didn't really work. But now, flash forward almost a decade later, they're actually starting to get some results of spinal cord implants, but a little more complicated than what we were working on. But then I always liked metallurgy. I did one of my summer, I was a 3B student, one of my summer internships, I worked in Sweden creating heat treatment gases. We tweaked the catalytic process to crack propane for a carburizing atmosphere, to make a carburizing atmosphere. I also taught a casting class down in the old foundry that you guys will never see again. And then I joined Tom's lab group for grad school and studied welding. Specifically, I studied welding. So that little smoke that Beaver has there, a lot of people would call it smoke if they walk by and saw someone welding. It's not really smoke. Smoke is the combustion product of organics, technically, from the aerosol science world. That's called a fume. A fume is the condensation from metal vapors making small little tiny particles. Actually, the primary particles in these little clusters are nano-sized, and nano-sized things don't really like to have that kind of surface to volume ratio, so they agglomerate together, surface forces bring them together, and makes micron-sized little clusters that are easily inhaled. So I studied that. I studied more the chemical characteristics for when I was in grad school, but the motivation was for health reasons, because welders can't really avoid the fume because their head's right now and they have to be close to what they weld. And so you either have to put them in like an astronaut suit, or you learn what they can tolerate breathing. So that's what motivated that. But my interest in health didn't go away, and so I actually decided to go to med school. So I'm a mud fud. No one's ever heard that term before. It's an MD PhD, but I did the kind of more expensive, longer way. Usually MD PhDs need it because they got funding to get a PhD, which also pays for med school. Cheaper way. But if you are considering going to med school, but you like research, not really sure you want to, it's not a bad way to go. So went to med school at Ohio State, and so Ohio State performed Paramount's football. If you know anything about football, you'll recognize at least one of those guys. And then I did my internship in general medicine up in Vermont, and so this knows nothing compared to what I saw when I was an intern. And then I was down residency at the University of Virginia. That's Monticello, which overlooks the University of Virginia. Thomas Jefferson would sit up there while they were constructing the University of Virginia with his telescope and watch the little people build his they call it Mr. Jefferson's University. It's a different type of snobbery down there. Or pride, I should say. And then I'm going to continue residency this July at Harvard. So, and this year I'm taking a break to work with Tom. So why do you guys care about what I'm going to talk about? I'm going to try to convince you that you should care. Okay. You're like, I'm an engineer, I don't really need to know about this human body stuff. I'm going to go work in foundry, or I'm going to go work in some construction fab, or what have you, I don't know. How many people have no background or interest in biomedical stuff? You can tell me. Sure, okay. So the rest of you do have some interest? Okay, that's cool. So I may not need to convince you guys too much. But first of all, engineers are patients too. So some of what I'm going to talk to you about, I'm sure you'd find interesting. Hopefully, you guys are all fairly young, so hopefully you've not seen a doctor. Those of you that might have, you don't need to tell me that, but you may know a lot of stuff already just as a patient. But I can tell you from patients that I've had who are engineers take a lot of interest in what doctors do. They ask a lot of pointed questions, so I think you'll find this interesting just as a patient or a future patient. You knock on the wood, you don't have to see one. Some of you may think about going to med school, and I can talk to you about that about how engineers make good doctors. The number one reason that we decided to talk about this, Tom and I decided to have this module is Tom's taught a module on non-destructive testing or evaluation in the past, but focused on structural materials, inanimate objects, steel, welds, and looking for cracks on an airplane or something like that. Many of the same techniques are used by physicians, so there's a lot of overlap. So some of what I'm teaching about the human body will also apply to things that you may use as an engineer and controlling company, for example. Finally, there is an economic need for this kind of knowledge, and we'll talk about that. So I mentioned being a pre-med. Just a quick slide on that. So a lot of pre-meds in the meet are bio majors. You got friends that are pre-meds or biology, or there's the chem E, like the light chem E major that's out there. And the reason for that, a lot of reason for that is there's a certain kind of bias amongst physicians towards bio. They did bio when they were pre-meds, and so they kind of push it. The Harvard Med School website says this interesting phrase: biology is the most elegant expression of chemistry, physics, and math, which I find kind of interesting. I don't know if it's the most elegant, but they definitely have a bias towards it. And whenever you look at med school requirements for what you have to take before you go to med school, they always list biology first, even though you need twice as much. So there's a certain bias for biology. And yet, in my personal experience in medical school, less than 40% of the pre-clinical years, so the first 2 years of med school, you're not in the hospital. The last 2, you are in the hospital. Pre-clinical years are just book work, memorizing stuff, basically. I'd say about less than 40% of it was based on cell bio. And more than 40% of it, maybe 50 or even 60% of it, you needed a good physics or even engineering background to really understand well. Sure, if you can memorize it, you don't necessarily need to understand it, and that's what happens a lot of times with medical students. They don't necessarily understand the more abstract physics concepts, they just memorize the equation. But the engineers, they go through it, they do understand it, and they're really in a good place to be, because when you're a clinician, you're not really doing biology, right? You're not looking at a microscope at a person, you're looking at an individual who's, the mechanical forces are much more important than what the forces are on their cells. So I'm definitely biased about this. I think being an engineer is a good preparation for going to med school. But there is a caveat. Engineers don't learn to memorize in their undergraduate. And so a lot of people who go to med school who are like biology majors, they do memorize a lot. They just like biochemistry, a bunch of memorization, like there's all these amino acids you have to learn and things like that. Or even better, some of the humanities majors, they memorize a lot. Learn a foreign language, you have to learn a lot of different words. That's probably more similar to what you do in medical school than anything else, learn a foreign language. But anyway, anybody who's interested in pre-med, I'm happy to talk more about that. I'll move on. So I mentioned that there's similar techniques used in the non-destructive testing of the common structural materials that you think about, and compared to what we use in looking at the human body. You don't really, so palpation, does anyone know what that means? Raise your hand. Okay, so for those who don't, that's okay. Medical terms, and if I use a medical term you don't understand, just raise your hand. It's pretty normal, because doctors like to obscure what they know by using fancy terms. It means to touch. Palpation just means to palpate, just means to touch, to rub. You don't really do that much, like with a weld, right? You can go feel it, you might, but it's not really something that you can talk about. Visual examination is actually something that is the first thing that you do in both medicine and as particularly if you're doing a failure analysis. And a lot of engineers won't necessarily think about it, and some doctors don't talk about it either. But your eyes are actually really have a very good depth of focus. You can see differences that are really hard to see in just a picture, right? Because the picture doesn't have, first of all, the picture is still, you don't move it. But even if you use like a really fancy microscope and are able to move it around live, it still doesn't have the depth of focus that the human eye has. So when you're looking at something, trying to figure out why something broke, there's seats up front here. Like everyone on YouTube will see how you came in late. That's okay. Not joking. That's fine. You guys are the only ones who don't watch this. People like you. So you got to look at something. You got to think about it and process it. So I'll talk more about this here. Endoscopy. So that's using a fiber optic strand hooked to a camera to like snake the end of the fiber optic into some place that you can otherwise get your hands or eyes into. So we do this in both structural materials and with the human body. I won't talk a lot about endoscopy. I might at the end of the course, at the end of the module, we have to, but it's pretty straightforward. You can use lasers a little bit. Thermography. Thermography is using something to detect heat. You don't really use it a lot in medicine. Don't really use it a lot in like most non-destructive testing, but it is used. Like we have a camera that we can film video of like a thermal map, which is I can bring it in someday if we have time. There is some question whether or not they might be able to use it to detect breast cancer, but right now, if you hear someone mention that for breast cancer, say, well, that's kind of unproven.
Neil?
Yeah.
You may not want to say much about endoscopy, but I doubt, has anyone here ever had an endoscopy? Okay. Through the nose?
No, through the mouth.
Through the mouth, okay. I've had it through the nose twice.
Yeah.
And when they go up through the nose and stick something up your nose and goes down about 10 inches into your windpipe or whatever, it's an odd feeling.
Yeah.
Okay.
Yeah. I've gagged several people doing that. It's not fun. From their perspective, I haven't had that. Well, actually,
it's just a fiber optic cable, and it doesn't hurt, but you do want to gag.
yeah, I've had it done once to me, and I don't. So different people have different gag reflexes. I don't really have a big gag reflex, so I don't remember it being that drastic. But some people really bad, and when they've had treatments done, so a lot of people that need endoscopy done have had disease or surgery or something done around there, and so they get very sensitive. So it's not a trivial thing. I didn't mean to trivialize it, but there's other things we want to talk about first. And if we get to it, we get to it. Ultrasound's the big one for both medicine and for structural materials. It's growing in medicine. There's a lot of people who reject that every time you go for a physical exam, they're going to pull out an ultrasound. At least they're in the ER. They're talking about doing it in the ER. Every time you go to the ER, pull an ultrasound, do something. Because it's non-invasive. It really doesn't hurt you. It's just, so we'll talk about ultrasound. I'm not going to talk a lot about dye-penetrant and magnetic particles because it's not really something that's done in the human body. But it's about half, by volume, probably about half of what's done in the structural materials world as far as looking for cracks. Basically, you either use magnetic particles or dyes that will kind of localize to a crack and show a crack that may not be visible to the naked eye. Eddy current, I kind of made it look like it's analogous to doing an EKG or an EEG or EMG. It's not really. They're two different things, but they're both using electric potentials. Eddy currents, you're inducing using a magnetic field to induce a current, and you can find cracks because of how the signal changes. And then an EKG is when you put leads on someone's limbs. It's an electrocardiogram. French guy came up with it, I think, around the turn of the century, 1900 or so. And you're just looking for the change in electric potential over your heart. So the leads on your limbs, you can see that. And based off of which leads you're comparing the voltage drop over, you can think about the morphology of the heart and figure out how the heart's beating. EEG is electroencephalogram, so you put leads on your head and look for electric signals in your brain. And EMG is electromyelogram. You're sticking electrodes. It's a little bit invasive. It doesn't hurt that much. Stick needles into your muscles, and when you tense your muscle, there's going to be electrical currents get there. And I can talk more about those things. Again, that may be more later in the course. More important is X-rays. So, anyone have an X-ray done? I've had X-rays. You don't feel them, right? Don't see them, right? But you come up with images because of the different densities in your body. Same is true when you're looking at, like, if you're looking for gas porosity in a well. You can see bubbles of gas because they're much less dense than you see around. I'll talk a little bit about MRIs, magnetic resonance imaging. That's kind of unique to the human body because it depends on hydrogen bonds, right? We don't really do MRIs of polymers. That's the only real hydrogen bonding that I can think of in structural materials, but definitely don't do it for steel, so it wouldn't work. Why wouldn't it work?
Magnetic field.
Yeah, you would cause a major hassle. You'd get like technicians jump on you if you ever tried to bring any kind of steel into an MRI because it's a huge magnet. So it's a big enough magnetic field. Definitely, if you're about this close to it, you can pick up a hammer. So you don't really want hammers flying around the room. It's kind of dangerous. And then you can also get images if you inject someone with radioactive material. It's kind of specialized. I'm not going to talk too much about that because it's more for functional imaging, like looking for metabolic process of the body that's a little bit beyond just the engineering course. So, why should you guys care about this in general, just as citizens? That's because the GDP, the gross domestic product in the United States, is about 20% healthcare. That's a lot. 1/5 of all the money in the United States that's being generated is something to do with healthcare. And it's a little bit more than other countries. There's reasons for that. It might be, so this is a little tangent. You don't have to remember all the next few slides, but Americans spend more on healthcare maybe because we make more. We choose to spend more on healthcare. That's part of it. Also, the medical system in the United States is kind of biased towards the specialists, the way they're reimbursed. They get a little bit better funding, so and they also are seen more than what you'd see in other countries. There's less of primary care seen in this country than in other countries. Drugs are a little bit more expensive in the United States. We also have direct marketing from pharmaceuticals to the patient, which is banned in most other countries in the world. So you get people coming into a doctor, I want Nexium, and the doctor's like, well, you don't have to take Nexium. Actually, there's generic Nexium, it's not a good example, but often the drug companies are trying to convince the patients to take a non-generic. It's more expensive. There's more spent on administration for every dollar spent in the United States on healthcare. It's something like 20% of it goes to administrative costs. That's lower than in other industrial countries, and that's in part because of our complicated insurance-based way that we pay for healthcare. That's what third-party payer means. So, third-party payer is someone who pays for something that you are doing. If you're doing business with someone else, a third party is someone else who pays for it, right? So you as a patient comes to me, see me as a doctor, we're having a business transaction. And in the old days, back in like the 1800s, I would say, okay, I'll figure out what's making you sick, and in return you pay me a cow, or what have you, or $50 or whatever. And then insurance got involved, and now both the doctors and the patients have no idea what it costs to see the doctor. It's true. I tried to figure out once how much, so we were going to get this guy some treat for he had cancer in his bones, his back, and was causing a lot of pain. We were going to help treat that. And there's a special radiation process that you can do to relieve that pain. And the guy was going to pay out of pocket, as it turns out. So I wanted to make sure he knew what he was getting into because I didn't want him to find out, because I knew it was kind of expensive. I didn't want him to find out like months later when he got the bill what he agreed to do. So I just thought it was a thing to do. It took us like 2 days to figure out how much it would probably cost, and even then we weren't really sure. And it looked like it was going to cost about $20,000. So that's kind of an extreme case, but I bring it up in that it's a mess, the financing. So anywho, defensive medicine means people, like doctors doing treatments or tests on a patient because they're afraid they might get sued if they don't. And sometimes people get too many tests, which is expensive, tests that may not really matter. And so does it help us? Not necessarily. That's a graph showing the life expectancy in other rich countries compared to that in the United States. We're definitely different. We spend a lot more in healthcare and we die sooner. Why is that? Actually, we don't die necessarily sooner. If you're 7 years old, you probably do better in the United States than you do in other countries because we take care of our elderly here. If you got cancer, you're more likely to survive in the United States. We have better outcomes for cardiovascular health. For people who've had a heart attack, are more likely to have surgery here in the United States. If they people who have diabetes, in the United States, they meet standard goals, like they get their blood sugar down, they're more likely to get down in the United States. So we care for people who have advanced disease. What seems to be the problem is we're not caring so much for people who don't have disease yet. So you guys, for the most part, like you guys are all healthy, and how many of you have seen a doctor in the last year? Wow, that's pretty good. Well, it could be bad. Hopefully you've seen it for benign reasons. But a lot of people don't see a doctor in the United States until they have a very advanced disease. And then we spend all this money trying to treat that advanced disease. That's kind of expensive. It would have been better to prevent it at the beginning. So, and it tends to correlate. So you guys, you raised all your hands for seeing a doctor. That's in part because of the socioeconomic class you're coming from. You're at MIT, even if you didn't come from a middle class or upper class kind of level you are now, just by nature of your education. And so there's a lot of people in the United States who don't know that they should go to the doctor when they start getting a sore or a pain somewhere, because they just never were taught that. So when I was down in Virginia, we got a lot of patients from eastern West Virginia, and people would come in with a tumor the size of a basketball. I'm not kidding, I've seen this. And you're like, at what point did you decide this was a problem? At the size that was a ping pong, tennis ball, basketball, like that doesn't make sense to us because we are experienced, we've seen problems like that when we have family that know about these things. But some of the people I met, they really had no clue. So that a lot of that's education. So we have a lot of education disparities and socioeconomic disparities in the United States that affect healthcare and have nothing to do with how we fund healthcare. So anyhow, the other big thing is we're more obese in the United States than in all the other industrialized countries. And so that has a lot to do with socioeconomic issues too. You look at maps of the United States of levels of obesity and you overlay them with maps of poverty, and it's really close to the point. So, but there's other issues there too. Anyway, I'll move on. So again, I said that about 20% of the economies from healthcare has been growing, that percentage, over time. Well, it's the entire economy, but also per capita. So it's not just everyone sharing in it. So why is that? Back in around 1960, back when healthcare was deemed to be a little bit more cost efficient, the average doctor knew the names of like 10 drugs. No lie. There were only like 10 drugs that really mattered. When I was in medical school, I was tested on 500 drugs. So I had to memorize 500 drugs in a couple of weeks' time and know what their classes were, what they tended to do, what their main side effects were. Big difference. Much more complicated world today in medicine than it was. And that's because we've made a lot of medical advances. So that costs money. Also, there's some demographics involved with that half the medical cost that you will spend in your lifetime in the United States, or the average person will spend in their lifetime in the United States, is occurred in like the last year or two of their life. So we're spending a lot of money working on the advanced diseases. So that's part of it. The other thing is and this is more relevant, and get back to why this course is pertinent to you guys. Medicine is a labor-intensive career. A physician, it's a one-on-one interaction. I'll show you an example of that. And you know that. If you've been a doctor, it's a one-on-one thing. Sometimes you see other people coming in, but how that doctor interacts with the patient is individualized. And it's not something that you can turn in, we try to, with bad results, but it's not really something that you can turn into an assembly line, right? You can't just have a doctor who, he checks your reflexes, and the next doctor listens to your heart, and the next, I mean, you can't make patients, patients are too unique. You can't turn them into widgets in an assembly line in a factory. And so manufacturing has made great strides in efficiency over the last 50 years, right? So at some point in one of his lectures that Tom was teaching, he might mention that the cost of steel hasn't changed in real dollars since the 60s or 50s. That's kind of remarkable. That means efficiency, not real dollars, nominal dollars, I'm sorry. So that means that the efficiency of making steel has gone up, right? So, but the cost of a physician's visit, just an office visit, has outpaced inflation, and that's in part because it's labor intensive. Like all wages are going up because of manufacturing, other efficiencies in non-labor intensive fields. But you can't really take the physician out. Only you can't have a physician doing 2 surgeries at once. It just doesn't really work. It's kind of dangerous. So that's where you guys come in. So what you guys learn from this course, perhaps someday some of you might be able to work on a device or a technology that will enable physicians to be more efficient, to help with this economic pressure that we have in the United States, and help save lives. That may be through doing telemedicine, so treating people who can't see a doctor, can't see the specialist physically, but may be able to have a virtual reality enable a doctor's visit in their home, even though the doctor lives hundreds of miles or thousands of miles away. Using monitoring devices that I want to talk about will help. So, kind of skipping that. Skipping ahead, I guess. So, you've heard a lot about like biosensors and wearable devices. MIT's got a big wearables group. But essentially, there's all these different things that we can put on the human body to detect different kind of biological states. And the idea is that if we can reduce them down to something that someone can wear, something that doesn't hurt them when they use it, then A, they would use it more, it would become unobtrusive, they wouldn't remember that, they wouldn't forget to use it because it's just there all the time, like you wear a ring all the time. And that you'd have constant, continuous data stream going to both the patient and also to their doctors so that they can look for trends in their health. So, anyone have a Jawbone? You know what I'm talking about? The little thing that you snap on your wrist. Anyone use the Jawbone? I've not personally used it. I have a friend using it, but it's actually pretty elegant. It just flicks around your wrist. It's just a flexible band, flick on your wrist. It's just like wearing a watch. No big deal. And it does what it does fairly well, but it doesn't really do much more than that. So it has an accelerometer in it, and so using the accelerometer, you can tell when you're sleeping if you're turning a lot. If you're turning a lot, you're not really in a deep sleep. If you're not turning much, you're in a deep sleep, and so it kind of tells you when you're sleeping. It also can tell how much you're walking, and so it has an algorithm to estimate how much you've walked that day. So that's not exactly caloric burn, but it claims it is, but whatever. So it's kind of limited. It's not really, for me as a doctor, someone came in and said, this is my sleep schedule the last couple of weeks. Unless I was a sleep doctor, I'd be like, okay, it's not really that big of a deal. So Samsung showed this in demo. I don't know if they're going to actually make it work, but they're claiming that they can get it to work. It's called SimBand. They're actually using optics and acoustics in the band itself to like go into your skin and somehow get your heart rate, your pulse, your blood pressure. That would be a lot more interesting to me as a doctor. More interesting in the huge market, and it's really probably the biggest driver, is glucose management or glucose monitoring. If anyone here, I'm not going to ask people to tell me if there are medical conditions because that's not fair to me. paper, but a diabetic has to poke themselves a lot to get blood, right? Every meal, they're like pricking their finger, getting some blood out, and seeing how much sugar's in their blood, and so that tells them how much insulin they need to take. How much easier it would be if you just had, like in this mock-up, if you just had a little pad here that had it. That what they do is they actually use a needle, but it's just a small little needle. But I mean, it's still a needle, but it's better than pricking your finger every meal. Just sits there, and they just announced that they're going to have an app on Apple's new smartwatch to tell you what your glucose is in any moment of the day. That's a lot better than pricking yourself every meal, perhaps. There's a research group out in California that is developing a temporary tattoo, that, or a patch really, that supposedly measures your glucose, the blood glucose through your skin, with no needles. And then Google bought up a group that is working on using the fluid in your eyes as the source, or the surrogate for measuring the glucose in your blood. They measure the glucose in the aqueous fluid around your eye, and they do that through contact. So that would be really cool, and, but that's still in research as well. So there's lots of different things that people are trying or talking about. Some of these are really more vaporware than actual hardware. But you can see over here, most of them have to do with movement, heart rate, and sleep. Some are starting to get into measuring your body temperature, which just putting it on your watch, I don't really care what the temperature of your wrist is, because your wrist can get cold. I mean, that's why we wear gloves, you know. Like, that doesn't really tell me a lot of what the temperature of your inner body is. So measuring temperature is not as easy as you might think. People talk about skin conductance, and there's lots of what that means. I don't know. And brain activity again. What does that mean? People are making up these devices, and some of the medical implications are kind of made up. Glucose is a big one. Oxygen level is interesting, and actually I'm surprised not more people are into it because it's not that hard to do. We'll talk about that. And blood pressure is pretty big, but it's a little hard to do blood pressure. And I'll talk about how we measure blood pressure and why that's hard to do with a wearable device. So lots of different things out there. It's a big field to get into, and there's what I'll talk about in this course will educate you on why this field is challenging and interesting. So again, about this field, it's a growing field, but there's challenges. Most people stop using them. That's why I was curious about anybody that had a job on, because I've known people who get the job on and use it for like a few months and they stop using it. Because I think for the job on, it's comfortable. It's just that they just don't see the point because it doesn't really tell you a whole lot. So, kind of talk about what I'm going to cover in this module, and now what I want to do. So first, we're going to talk about what we call the physical exam, and you're like, what's that mean? Most of you have seen a doctor. I think you have an idea, but what I'm going to show now is a video of what a thorough physical exam is, which you don't get every time you see a doctor. In fact, most of you, when you've seen a doctor, probably spent most of the time talking to him, right? And what he did is what we would call a focused physical exam. He would have looked just at the part of the body that you were talking to him about. In young people, you're not usually going to do a comprehensive physical exam. That's because young people are healthy. If you get someone my age or older, sometimes you find diseases that the person didn't know they had by doing a comprehensive, complete physical exam. Anyway, this is a video of that. And, there's a little flavor, as an aside, there's a little flavor to this exam because this video is from a school of osteopathy. So you may hear, you look into medicine, you look at doctors, you see some are called DOs, doctor of osteopathy, and others are things like medical doctor. He's a DO. And so doctors of osteopathy nowadays are exactly the same as an MD. A DO does everything an MD does. But their tradition, they started at the same time chiropractic started, and they did similar spinal manipulations. And so even today, there's still kind of a flavor in their exams. He focuses a lot more on like her range of motion and just her how her spine is. And MD might not do that thorough of the musculoskeletal exam. So, any questions or requests for future discussion during this module? Okay, that's fine. Makes it easier for me. That's, yeah.
You said you're going to explain what the percussion of the liver was
Yeah.
for? Is
Yeah,
it during this
so-
class or another class?
Why don't we do it in another class?
All right.
But short answer is it's to see how big the liver is.
All right.
You guys have normal sized livers. You haven't earned a large liver yet through years of drinking. So, but yeah, that's usually the case. You have someone who comes in, smells like alcohol, and you start tapping around, and you can hear the hollow sound. You can do it on yourself. You can kind of hear hollow sound when you're down here, because that's your guts are liquid and gas, right? So it's kind of hollow. Your liver is a little bit more solid, so it's a little bit duller sound. I can demonstrate that more in another lecture. All right, that's all I have for today.
Sounds pretty touchy-feely to me.